What else do we need?
-2.
Now, -2 is interesting. We don't really need it because really we're looking at this area. However, we need to know what happens between this range. You see, what you're going to do is called a sign analysis test, and that means you're going to find the sign in this interval and the sign in this interval. The only reason why we need this number is to make sure that you pick something in this range. Because if you don't, if you pick something in this range, this is where the signs change from positive to negative. Does that make sense to you? So you have to find something in this little range and this range over here. It could be anything over here. But in this range, it's got to be between these two numbers. That's why we put the -2. We're not taking a limit to -2. We don't care. Really, we don't care. We want to find out what happens at the 5. Is that clear for you? Scott?
Are you talking about like the trig function sign?
No, no, this is easier.
Okay.
There's no trig functions here.
Okay, so I was thinking the same thing. Trig function is sign. I'm going, okay, let's see how we're going to get there.
Where's these trig functions coming from? Darn it, I hate calculus. No, there's no trig functions. This is basic. Okay, this is just plugging in some numbers. Sine, as in I am signing. Okay, sign, like yes, sign. Sign.
Like a sign.
Like sign. Oh, I get it. Sign like sin. No, we're not sinning. We're signing here. No, we want the sign. Let me write that. Sign analysis. Analysis is another one of those things you can't really abbreviate that well. Analysis. Got it. The sign analysis. That'll go viral on YouTube. That'd be awesome. So again, the reason why you have to have the -2 is because your sign will change in these two intervals. And we don't care what happens here, but we want to make sure we pick the correct number for this interval. We don't want to be picking -3 because it's going to give us the wrong interpretation of what happens around this. Now, you have to know what happens around the 5. And you already said it once or twice before. Is this a whole or an asymptote? It's an asymptote because I can't get rid of it. You follow? So you know for a fact it looks like this. You know for a fact that you have an asymptote right here, right? So you're going to be in one of 4 situations. Watch carefully. You are either going to be going like this, true? Or like this, or like this, or like that. It's one of those 4 situations, and the sign analysis will tell you what it is. Here's how you do it. I want you to take a number in this interval. What's a good number in this interval? Pick 6. You can't pick 5 because, well, obviously you can't pick 5. Pick 6. Plug in 6. And tell me what you get. Plug it in.
Not the original, but
No,
no. 5.
No, you know what? What you've done here is you've just simplified out a whole. It's going to give you the same exact answer. So plug it in here. What'd you get?
8.
You got 8 because you did 8 over. Wait, what'd you get? 6 plus 2. Oh, right. 8 over 1. 1. So 8 over 1 is positive 8. That's what I'm looking for. I really don't care about the value. I care about positive or negative. What'd you get? Positive or negative? Positive. Make sure you know how to deal with your signs. Okay? So you got a positive. You know what that means? If you got a positive, are you going to be going down to negative infinity or up to positive infinity? Definitely positive infinity because you're doing positives here. You know it's an asymptote already. Somehow you're going to be looking like that. You okay with that so far? Okay. Now, try another number in this interval. Again, the reason why we have the -2 is to stop us from going too far. So what's a number in here?
0.
Pick a better number than 4.
0.
Pick 0. 0 is a great number. It's an interval. So plug in 0. What'd you get?
Negative
2 over -2. So is it positive or negative?
Negative.
Am I going to be going up to meet that other asymptote at infinity? I'm going to be going... I don't really care how the graph looks. Honestly, I don't. I just really care what the asymptotes are, what the function's doing around the asymptote, because that's what the limit is. What's it doing around the number? Do I need to plug in a number over here past -2? No, this is just to stop me. So you got to tell me, does the limit exist, because we're talking about 5, does the limit exist at 5 or not?
No.
If it did, they'd both be going up or they'd both be going down. Okay, if they're like this, then it doesn't exist. But this is how you show that it doesn't exist. You don't just automatically go, I can't do it, does not exist. Okay? Because you could be wrong, all right? It happened before. It does not exist because you showed it with your sign analysis test. So on your test, when I give you a problem very much like this, which I will do, and I ask you to show your work, Or I might even say, show a sign analysis test. That's what I'm talking about. I need you to prove to me that that limit does not exist. So if they say, show the limit doesn't exist, that's it. Okay? If the limit does exist, you'll be able to simplify out the holes. If it doesn't exist, well, then you have to show a sign analysis test. Show that you have an asymptote, and it's going like that, or some other way that you cannot make those things go together. How many people understood that? What we were just talking about? Good, all right. A couple notes for you, so I'll write this out so you can remember it later. First one. If you get 0 over 0, what that means is you have a common factor at that point, x minus that point. So if you get 0 over 0, what you're going to try to do is factor and simplify. Factor and simplify. 90% of the time that's going to work just fine. That's these examples over here, all right? The other percent of the time, let's say you factored, you simplified, you still have an issue. So that's number 2. If you cannot simplify the problem, okay, if you can't get rid of the problem, if you can't, we'll say it this way, if you can't cancel the problem, because y'all love the word cancel, right? If you can't cancel the problem, that means it's not a hole. If you can cancel the problem, it's a hole. If you can't cancel the problem, that means you have an asymptote at that point. What you're going to need to do is evaluate it with a sign analysis. So two situations. Holes, cancel them. Great, done. Not holes, those are asymptotes. Sign analysis will show you what that does around the asymptote. If they go into the same thing, it exists. Positive infinity or negative infinity. If it's not, then it doesn't exist, and that's the only way you can show that for us. So if you cannot cancel the problem on the denominator, check with sign analysis because the limit might not exist. Because the limit might not exist. How many people feel okay with what we talked about so far? Okay. I'm going to show you a couple more very unique examples. We'll talk about those. Things you really have to know exactly what to do when you see them. So I want to make sure you see them.
I started writing in all caps thanks to you.
You're welcome. My handwriting is so atrocious. That means bad. So condescending what I just did to you. That's horrible. Sorry. It was really bad until I started writing in all caps, and now I have trouble even writing limit like that. Also, my dad was a carpenter and a draftsman, and so he used all caps all the time, so I wanted to be like him. So I started doing that too. So he's much better at it. All right, now, we got this situation here. Limit x minus 1 over square root of x minus, oh my gosh. Well, the first thing you try to do is what? Try to plug it in. Do you have an issue?
Yeah.
Now, you have 0 over 0, true? Unfortunately for us, these aren't easy to factor, right? You probably do have some sort of factor out of that, but it's not easy to do. Polynomials are easy to factor, that's fine. But with this, that theorem really doesn't hold that much water because it's not easy to factor that. So, okay, what are we going to do? Any ideas? Have you ever heard of the conjugate? The conjugate is those two terms with a different sign in the middle. If we do that, that's one way you learn in your intermediate algebra course on how to rationalize a denominator or rationalize a numerator or basically just rationalize out a square root. So if we do that, that might help us. So don't forget the algebra that you know. Sometimes we can rationalize. If we do, we'll rationalize square root of x minus 1. Oops, sorry, plus 1 over square root of x plus 1. You have to use the conjugate though. If you don't, well then you're going to just make your problem worse because you're not going to get rid of the square root. It's going to be within a middle term of your problem. So you have to alternate those signs. You guys okay with that? You sure? So use that conjugate. Now let's see. Of course we have parentheses here. Now I'm going to give you a little piece of advice. Generally, you don't want to distribute, in this case, the numerator. If you were rationalizing the numerator, you wouldn't want to distribute the denominator because ultimately you're trying to simplify out something. Are you with me on that? You're trying to simplify that out. So I'm purposely not going to distribute the numerator unless I absolutely have to if I run into an issue. So right now I'm going to leave this as x minus 1 and the square root of x plus 1. Why? Because I'm trying to simplify stuff. That's why. Now on the denominator, you tell me what do I have to do with this? I do have to FOIL or distribute, so that means every term times every term. Tell me, what's square root of x times square root of x?
Yes.
Now, do you see what happens and why we use the conjugate? If you distribute this, we get x, we get plus root x, we get minus root x. What's going to happen with that? That's why we use the conjugate. And then lastly, you're going to get what? You get x minus 1. Do you see why we don't distribute the numerator? If you distribute the numerator, you gotta mess crap up there, right? You have to refactor. It's not going to be easy. If you don't distribute it, the factoring's obvious. The simplification is obvious. What are you going to simplify? Well, at least I hope it's obvious. Is it obvious to you what you're going to cross out? All right, good. Yeah, kind of obvious. All right, well, our limit as x approaches 1, notice I'm still writing limit, is this, well, what do we have left? Are you going to have an issue? Oops, that doesn't look like an x. Are you going to have an issue if you plug in 1? It's not negative, it's positive 1, so we're okay. We have no denominator anymore because we rationalized it. It went away because we were able to simplify it. If we plug in 1, what are you going to get? 2. And that's your limit. How many people feel okay with this so far? Would you like to try 1 on your own? Let's do that. I'm going to give you a little bit more complicated of 1. Not too bad. And if you get stuck on it, no big deal. That's fine. But I want you to at least think about it while you're here. This will be where we end today. So limit as x approaches 0 of the square root of 1 plus x minus 1 over x. Are you going to have an issue here? Yeah, I mean straight up we're going to 0 and that's over 0. That's a problem. So what could you possibly do?